In this lesson, we are going to learn how to draw atomic models. We need to remember that when we draw atomic models, what we're really drawing is we are drawing what's known as Bohr models, named after Niels Bohr. And they're called Bohr models because they kind of follow his onion model pattern with different shells or rings. So it kind of looks like an onion, especially this one that's cut in half. Well, when we're talking about drawing atomic models, we need to talk about electron shells. And electron shells are sometimes called orbitals, levels, or rings, and we can call them all of those different things. Eventually, if you go on to chemistry, though, they do become what's known as orbitals, and that is the more correct way to talk about these things. Well, for the 8th grade level, we're really only going to be drawing atoms with 3 shells, or up to 3 shells, I should say. In the first shell, you can have up to 2 electrons. You do not have to have 2, but really only hydrogen is an element that does not have 2 in the first shell. In the second shell, you can have up to 8, and in the third shell, we can have up to 18. So these are the numbers that we're going to need to remember. So first shell can have up to 2, second shell up to 8, and third shell up to 18. We're now going to try to practice some of these things. And we're going to start right here with the element helium. And helium is on the periodic table, and it is atomic number 2. So that 2 in the upper right-hand corner tells us that there are 2 protons and that there are 2 electrons. Remember, we are using the plus to indicate protons, the E to indicate electrons. In order to calculate the next number, which is neutrons, we take a look at the bottom number, which is the atomic weight. The first thing that we do is we round that number to the nearest whole number, so that would be 4. We then subtract the atomic number, which is 2, and that gives us 2. When we do the neutrons, we always have a math problem involved. Now that we have these, we need to remember that the protons and the neutrons are what's inside the nucleus. So we'll draw down here, a positive, or protons equals 2, neutrons equals 2. And then we talk about our electrons. We need 2 electrons, and since we need 2, and there's 2 that can fit in the first shell, we put those in the first shell, and then we draw that shell around. There is a picture of helium. Let's try a different one, beryllium. Here's beryllium. First, take a look at the atomic number. Beryllium's atomic number is 4. That tells us protons and electrons. We look at the atomic weight, or mass. We round that to the nearest whole number, which is 9. We go 9 minus atomic number, which is 4, which is going to give us 5 neutrons. 4 protons in the nucleus, 5 neutrons in the nucleus. We then look at the electrons, which is the letter E. Then we need 4, so we can put 2 in the first shell. We can't have more than 2 because it can only hold 2. We still need to put 2 more electrons because we need a total of 4. So we put 1, 2, and there is a model, or a Bohr model, of beryllium. More. This one is silicon. So silicon, we take a look at that atomic number being 14. Put that for protons, put that for electrons. We then use the atomic weight, which is 28.086, which rounds to 28. Subtract 14, and we get 14. So now we're ready to draw. Protons equals 14, neutrons equals 14. There's our nucleus. We need 14 electrons, so that means we need 2 in the first shell. 14 minus 2 is 12, so we need 12 more, but only 8 can go in the second shell. So 1, 2, 3, 4, 5, 6, 7, 8. There's our second shell. Very clear that the second shell is different than the first. So then we've got 2, 4, 6, 8, 10 electrons right now. So now we need 4 more in order to make the 14 that we need. So we'll put 1, 2, 3, 4, connect those as our third shell. And then that is a model of silicon. It does not necessarily matter where you put the electrons in this outer ring. However, it's important to make sure that when you're drawing all of the rings, no matter what ring you're drawing, that it's clear that they're on the different shells, either first, second, or third. And that is how we draw Bohr models.